Here we go, final lesson for matrices. So in this one, we're now looking at how do we use an inverse to solve a system of equations. So in the last lesson, lesson 6, we just found how to find the inverse, and now we're going to use it to solve a system of equations. So the key thing I want to point you to is this right here. So this comes right out of our last lesson that we just did, where if this is the equation that I'm starting with, if I want to get x by itself, I have to take the inverse of matrix A and multiply it over to here. So that's what you're seeing is sort of the ultimate setup is this. And so that's the goal as we go through this. So I'm going to show you the first one that's already been done, and then I'll walk through the second one on my own here so you can kind of see it all put together if you need to. But anyway, here's our system of equations. So we're just using a set of 2 for this, so just x and y. So we're going to call the left side matrix A, and we're going to call the right side matrix B. And our goal is to basically just solve for x and y, and that's going to be this guy. So it starts out with creating what we call our coefficient matrix. So the 2, the 3, the 1, the -2, those guys make up our coefficients. All right, so that's this guy right here. So that is matrix A. And we're going to take the inverse of that matrix and multiply it times matrix B in order to get our solution set that looks like this. So real simple on this, I just need to find the inverse of this, multiply it times that, and that's all we got. So inverse process that we learned last time was it starts out by doing 1 over the determinant. So here's matrix A, my coefficient matrix. So if I do the determinant, which would be -4 minus 3, gives me that -7, that goes on bottom. I then bring in what we call the altered matrix, so that's where these guys trade places. So that's what you're seeing right there. And then these guys change signs. So both of those became negative. So I have 1 over the determinant times the altered matrix, and that's going to give me my inverse. I'll then multiply that by matrix B in order to get my answers. Something I talked about in the last video is there's kind of a nice way of avoiding the fraction work by just simply saving it till the end. So instead of distributing it right now and creating some fractions, I'm going to multiply this times this first, and then I'll bring in this at the very end, and that way I don't have to deal with those fractions. So I'm multiplying my top row times the column, that's the 21. Then I'm doing the bottom row times this column, that's my -49. Now I'm going to bring in that -1/7, and I distributed that to both of those guys, and there's my solution set. So the one on top is my x, and the one on bottom is my y. So that's the full process. I'll kind of walk through the second one here, so if you're looking to follow along these notes on your own, you can kind of see the full process that we would do. So starts out by just understand that I am looking at matrix A times, I'm going to write it this way, times my solution set equals my matrix B, which is the 8 and the 2. So matrix A is our coefficient matrix. So if I take the 3, the 2, the -2, and the -5, that is matrix A. And we're going to find the inverse of that, and we're going to multiply it times matrix B, which is the constants on the right. And that's going to give us our solution for x and y. So let's find the inverse of this guy. So if I did my determinant, my downward minus my upward, I get this. So -15 plus 4 is -11. So we're going to do 1 over the determinant times the altered matrix, which is where those two trade places. And these two change signs. So it becomes +2 and -2. And then we're going to be multiplying that one times matrix B, which is the 8 and the 2. And again, here's kind of the nice way of approaching this. I could distribute my fraction now and then multiply this times this, but that just can be tougher, and then you have all these fractions to deal with. So instead, I'm going to save the fraction till the end, and I'm going to just multiply these guys first. So if I did my top row times my column, so -40 plus -4, gives me the top row, and then my bottom row times this, so 16 plus 6. Now I'm going to bring in my fraction, and if I distribute that, top guy would just become 4, bottom guy would just become -2, and that's my solutions. That's our solution matrix. So the top one is always going to be your x, and the bottom one is always going to be your y.